The length in feet of a small train at an amusement park can be modeled by the function f of c equals 9c plus 14, where c is the number of passenger cars attached to the locomotive. The original passenger cars were replaced, and the length of the train is now modeled by the function h of c equals 12c plus 14. Based on this information, which statement describes the change in this situation? Okay, we're not going to read any of those answer choices yet. Okay, we need to first understand the situation. All right, I suggest getting some other paper, whatever paper's available to you, the front of the test or something, for these problems where you might need some extra paper. The other thing I really recommend is writing the equation down separately, away from all the wordy stuff, all right? So we're going to go ahead and rewrite this. F of c equals 9c plus 14. We need to understand what's going on with all this. C is the number of passenger cars attached to the locomotive. So these are passenger cars. Well, think about a train. What's a train made of? We have locomotive. There's only one locomotive. And there's a lot of passenger cars. Now, just looking at where the 9 is and where the C is, it looks to me like the 9 has something to do with the passenger cars, right? In fact, it's looking like the 9 is the length of the passenger car. Say we had only one passenger car, that would be 9 times the one passenger car, that gives you 9 feet. I'm thinking that's in feet, is it? Yeah, it is in feet. Plus the 14. And what is the 14? It only happens once, right? We know this number as several things: the starting value, the one-time number, the constant. It's all of these things, right? And what's only happening once in this situation? The locomotive. So this is the length of locomotive. There's only one locomotive, it's 14. And say there's 5 passenger cars. 9 times 5 would be 45. That's the total length of passenger cars plus the one-time length of the locomotive. That would give you the entire length of the train. So this is the length of the locomotive. This is the length of each passenger car. And here's the number of passenger cars. All this stuff together gives you the total length of the train. All right? Do you see what we're doing? We're understanding the situation before we even look at the answer choices. Now what happened? It said the original passenger cars were replaced. Okay? We have a new equation now. The length of the train is now modeled by the function h of c equals, and I'm going to put a little wall here so that everything's lined up, 12c plus 14. So what's happened? The locomotive's still the same length, but now it looks like the passenger cars, here's the number of passenger cars still, but it looks like the passenger cars are longer. They were 9, now they're 12. Okay, now that we thoroughly understand everything, let's take a look at what's going on. Choice F. The locomotive is now 9 feet long and the length of each passenger car remain the same. That's totally wrong. The locomotive only happens once. That's why it's in the place of our one-time number, our starting value. Right? It didn't change. That one's not right. Choice G. The locomotive is now 12 feet long and the length of each passenger car remain the same. Again, we didn't change the locomotive at all. None of this has to do with the locomotive, based on our understanding of the situation. H. Each passenger car is now 9 feet long, and the length of the locomotive remained the same. Well, here's the thing. The passenger cars were 9 feet long, but with the new equation, they're now 12 feet long. So this is like old stuff here. They're not now 9 feet long. That was the first equation. Everything else is fine, but that 9 feet long is old news. Choice J, each passenger car is now 12 feet long, and the length of the locomotive remained the same. The locomotive did remain the same, and the passenger cars are now 12 feet long. There it is. It went from 9 to 12. So it's choice J.